Good day everybody and welcome to another one of James's videos. Today we're going to carry on with the trigonometry grade 11 equations and we're going to start our types. So type 1, the first one we're going to do, we are doing a solve for theta if theta is an element of 100 minus 180 degrees to 180 degrees. Okay, so now we know we're not dealing with a general solution, we are dealing with specific solutions. Reason being, they have given us a domain. Okay, and more specifically, this type, the previous one that we did was a sine cos example with a general solution as well as specific solution. We're now going to be dealing with a tan example, which is a little bit different. Okay, so what we're going to first start off by doing is we're first going to simplify the trig ratio to being by itself on one side of the equal sign. So we're going to divide both sides by 5. That's going to cancel those 5's out, which gives me tan of theta, or tan of 2 theta minus 20 degrees is equal to 16, if I'm not mistaken. Yeah, okay. There we go. So now that we've gotten that, a lot of people would have said, okay, James, do we now plus 20 and then divide by 2? No. We leave whatever is in the angle position. We leave this until our general solution step. Okay, so we leave the angle part until our general solution step. Now, what are we going to do here? We're going to go straight into reference angle. So reference angle, so we're going to go shift tan of 16 or 16. That gives me 86,42 degrees. Okay, now remember, when we do a reference angle, we don't take the signs into consideration. We always do it of the positive. Now, we've got cast diagram. Where is tan positive? Tan is positive in the first and the third quadrant. So that means that for my general solution stage, I would be doing first and third. But wait, how often does tan repeat itself? Tan repeats itself every 180 degrees. So with tan, guys, and tan in general solution and equations, we actually only have to do one quadrant, and it will either be the first quadrant or the second quadrant, depending on what signage your tan is. Now, if you had to do the third quadrant as well, it's not going to be wrong, but what you're going to realize is that you're actually repeating yourself. So we would have done first quadrant, and we would have done third quadrant. But this here answer is going to be exactly the same as this answer, or it's going to give you the same answers. Okay, so the reason for that is because tan does repeat itself every 180, hence why you only have to do either the first if your tan is positive and the second if your tan is negative. Now the first quadrant is known as the theta quadrant. So now look what I'm going to be taking. I'm going to be taking this angle that I'm trying to work out, and I'm going to put it here in my general solution step because that's what I'm trying to solve for. Equals my reference angle, which is the 86,42 degrees, plus k. I started with 360. It is 180. K is an element of integers. Okay, so the difference here with tan, we only do one of the quadrants, and we also know tan repeats itself every 180, hence it now being K180. And now we're going to do some algebra just to solve for theta. So we're going to bring the 20 over. It's going to change into a positive, and that's going to be 106,42 degrees plus K180. K is an element of integers. We then are going to divide everything by 2. So that gives me 53,21 degrees plus K90. So everything must be divided by 2. Okay, that is my general solution, but we are not looking for a general solution. We are looking for actual values because they've given me a domain. So now I can go ahead and sub values in for k. So if k equals 0, my domain, remember, I'm just going to bring it down here, is an element of minus 180 degrees to 180. So I'm going to say if k equals 0, therefore theta equals 53,21 degrees. Does that fall within my domain? Yes, it does. Now we're going to say if k equals 1, therefore theta equals 143,21 degrees. Does that fall in? Yes, it does. Let's try 2. Let's have a look. So if k equals 2, therefore theta is going to equal 233,21. Does that fall within this domain? Definitely not. So we don't have to include it. So we can rub it out. I'm writing it out just to show you, but what you can do is you can mentally maths do it in your brain to see whether it is going to fall in, and then you can decide whether you're going to put it in as a solution or not. The next one we can do is k is equal to -1. Let's see what happens there. So it's going to be 53.21 minus 90 minus 36.79 degrees. Does that fall within? Yes, it does. Let's try k equals -2. Therefore, theta equals. So now that's going to be 53.21 minus 2 times 90, which is 180. And that gives me minus 126.79 degrees. That falls in. Now, if I do -3, it's going to make the 90 minus 270. And if I go 53 minus 270, that is going to be still in the minus 200s, which does not fall within my domain. So therefore, my answers for this question, theta is going to equal, and remember we write this in ascending order, minus 126.79 degrees, minus 36.79 degrees, 53.21 degrees, and 143.21 degrees. Fantastic, and those are my answers for this question. So just a quick recap, everyone. We're dealing with a tan trig equation, which means that we are going to have only one quadrant that we are going to do our general solution and specific solutions in, because tan repeats itself every 180. Also, we did an example now where the angle is quite big. It's a binomial in this case. It's quite a big thing. So what we do is we ignore it until we get to our general solution step. So remember, this is where it pops up again. Okay. And that's where we solve for our angle. We do everything normally until our reference angle. We leave this alone, get our reference angle, and then we solve for the angle part in the general solution step. Okay, I hope you guys enjoyed this video. Please click the subscribe button and the like button below. And all these notes are available in the James book. So if you would like a copy of the James book, please comment and message us or get in contact with us, and we will get you guys a copy. Awesome. Thank you so much.